In today's class, we have already started with the concept of magnetization and permeability. Let me just quickly recall a bit. So, in this today's session, we will complete some equation related to magnetization. Okay. So, we know what is a magnetic moment. I said in the class we have discussed every body that is present, every entity that is present in the nature. It possesses magnetic moment. Okay, it is very minute when we talk about atom structure inside the atom, very minute detailing is required here. We sometimes call it magnetic dipole moment. It is denoted as a small m, but magnetization is capital M. So what is magnetic dipole moment? Suppose this is the revolution indicating the flow of current. Charges are moving, okay, with revolution and rotation both. If there is a field, okay, you can see magnetic moment is the current flowing. We call this bound current or amperian current, multiplied by the area that it covers. Okay, and direction is always perpendicular to the surface, and always the magnetic moment direction, and if you observe your field direction, both will be aligned. Okay, they are collinear with each other. In extra I have written this, okay, and may not be required, but remember magnetic moment is Ib into ds or s into an, and magnetic dipole moment is ampere meter square. Now, classification of materials also we have seen there are basically magnetic, non-magnetic and magnetic materials. Non-magnetic, I think I have given you the example of gold and silver. Again, they have two types, diamagnetic and paramagnetic. You can observe the permeability value. What is permeability? It is, um, the how much an object will permit the flow of uh, magnetic field inside it. That is called permeability. And diamagnetic materials are silver and gold example. Its permeability is very less. That's why I said even though they are superconductors, I said they are diamagnetic. Paramagnetic, it where the mu r value is greater than 1. Okay, moderate value. I hope it is visible to you. Here I have written from the pencil. Example, magnesium and lithium. Two examples I have got it, paramagnetic materials. And the other category is ferromagnetic, which we have even done one of the experiment in the class where the needle was taken, the coil was wounded around it, and we had connected the battery. So that needle, the needle, it started acting like a magnet. It started attracting the pins, right? I think needle, it was not needle, it was nail. So some of the examples are iron, nickel and cobalt for ferromagnetic. Now talking about the magnetization, capital M. Magnetic moment is small m, magnetization is capital M. How well the magnetic moments, the orientation, what is dipole moment, magnetic moment, the orientation of an object, okay, whenever the field exists. So how well an object, an entity can acquire the magnetic properties, we call it magnetization. In the class today we have discussed the moment of orbital electrons. There will be two moments here. One is spin, that is rotation and revolution, right? There were two different moments inside the atomic structure. Because of this, some internal field will be there. So whatever current is produced because of these bound charges, we call it IB, bound current or amperian current. Fine. This is about the bound current, which is totally different from the free charges, free current, what is conventional current, which you have seen in your semiconductors. Okay, and properly, if I want to define magnetization, it is the field produced due to the movement of bound charges. So magnetization, capital M, uh, any object will acquire the magnetic properties because of its dipole moment inside M, and dipole moment and all exists because of the spins, and because of spins field exists, as well as what, the current exists, IB. So whatever field is produced for magnetization, it is all because of the bound charges. Only IB is important here. That's why we write M equals to IB into S. It is not simply I. And talking about dimensions, both H and M are equivalent. You have studied about units and dimensions in your pre-university levels. I think one example I have given you. How will you find the dimensions? Velocity equals to distance by time. I hope it is visible to you. I have written it from the pencil. Distance is how you write the dimensions. You take L, M, T, right? Your length, mass, and time. These are the three entities you take. For time is capital T. So how will you write this in LMT? L raised to 1, M, you don't have mass here, M raised to 0, T raised to minus 1. So dimension wise velocity is LM T raised to minus 1. Okay, one example I have given you. How will you find the dimensions? So likewise, if I try to find the dimensions of H and dimensions of M, magnetization, both are equivalent. That's why in further equations, we will see that wherever we have H, we have studied in Ampere's law, in Biot-Savart's law, H value equations, there equivalently M is replaced. We will see that. Okay. M is generally represented in terms of small m. How we can express something like M is equals to some equation. Okay. We don't know what it is. We will see. M is equals to the magnetic dipole moment is IB into S in the unit vector direction, and this it is perpendicular to the surface. Okay, if I consider some volume, I think in the class I had drawn this figure. Suppose I consider some volume, differential volume. Within that, in nature, naturally, without applying any field, there will be no magnetization, because you can see how the orientation is. Dipole moment is in different directions. Alignment अलग अलग है. इसका value say m1 है, इसका m2 है. Maybe both are same here, but here it is different. M3 small m, okay, m4. All are different, so that we don't have any magnetization here. But in presence of external field, what will happen? They all will be aligned very, strictly. They all will align themselves so that magnetization, magnetic moment will be say m1, m2, all are exactly parallel to this applied field. Okay, in the class we have discussed this figure. Suppose I consider a differential volume, and there in this figure I think एक volume में 4 moments हैं आपके पास, m1, m2, m3, m4. Suppose I have n number of such dipole moments, n number of dipole moments, then total dipole moment is sum of all. यहाँ पर क्या होगा? For this volume it is m1 plus m2 plus m3 plus m4. Total magnetic dipole moment. So how you define magnetization is, it is defined with respect to volume. So capital M I can write it as 1 by delta V times. जितना volume आप shrink करोगे, that's why I'm applying the limit here. Considering that delta V, per delta V, okay, what is the total magnetic dipole moment? This will give you magnetization capital M. This is the equation for capital M, magnetization. Okay. And one more important thing here to remember, I told you here, the total bound current, I can write this in the form of a line integral, something like our Ampere's law. How we write Ampere's law? It is H dot dl. This is equals to our free current I. Okay, in the loop, whatever current is flowing because of the charges that are existing. Okay, that is your Ampere's law. If you just compare in analogy, I is replaced with IB, the bound current. There is a line integral. H is dimensionally equivalent to M. because of which I'm replacing that. Okay, but we have a derivation for this. Let us not go into that. Just remember, bound current IB is line integral of m dot dl. Okay, why I'm stressing on this equation is further we will see, we will try to derive some equation. Question will be something like, derive the relationship between B, H and M. B is your flux density, H is magnetic field intensity, M is magnetization. इन तीनों के बीच में क्या रिलेशनशिप है? ऑब्वियसली फील्ड एग्जिस्ट है, फील्ड में डाइपोल मोमेंट अलाइन होता है. How well a material get magnetized is capital M. So there exists a relationship between all the three. So we have to derive the expression, mathematical expression. For that, this equation will be helpful for us. That's why the total bound current IB equals to line integral of m dot dl. Okay, how this m dot dl has come, again further what we have done, I'll just briefly tell you. Some, you can see in this above figure, some 4 dipole moments are there, m1, m2, say m3. Out of which any one I have considered. See here, one dipole moment I have considered, but observe, it is not completely horizontal or vertical. It is something like a tilted structure, tilted, so that इसका dipole moment का direction ऐसे है, m is equals to IB into ds by the definition. Okay, so if I consider this, in that I am considering a differential volume. We need to consider a differential volume. Volume is actually what? Surface area into length. So I have split it, this volume into ds into dl. So hence the differential volume will be ds into dl. Okay, dv I will consider, which is equals to ds into dl. But ds into dl, again, as I said, ds has a vector quantity, dl is also a vector quantity, dot product. So ds dl cos theta. So I have substituted that here. Somewhere you can see that cos theta. Yeah, dl ds cos theta, or it is simply dl dot it's ds dot dl. Okay, for n such dipole moments, the total current will be n times this total. Okay, and we know IB into ds, this is nothing but your magnetization m. So in that way this equation has brought up, but however not required. Just आप इतना याद रखो, bound current is equivalent to, it is equal to the line integral of m dot dl. M is just analogous to here, equivalent to dimensionally h. Ampere's law में हमने देखा है. Now to derive the relationship, what we'll do, the total current, whatever exists, it will be in any material I'm talking, it is sum of this bound current, internal structure. Okay, bound current and whatever your free current, conventionally what you use in your menu of your analysis. For any circuit you consider, for semiconductors you have taken because of those free charges, right? So bound current and free charge current, both summation will be your total current. So I total is equals to IB plus I, and it is in general we know that current is equals to Ampere's law form, line integral of HDL. We know this, total current is equals to IB plus I, which is equals to line integral of H dot dl. So what I will do, IT will be equals to, instead of H I am substituting B by mu naught. We know that B equals to mu H. I am substituting this, B equals to mu H. So H will be B by mu naught. So I am substituting that here. From this above equation, what is I? Extract that. I will be IT minus IB. Current I, free current, what we call. Okay, free current is, I could have taken here this F subscript. Free current is equals to IT minus IB. So what is IT? Just now I have written, it is line integral of B mu naught dl. And what is this IB? Just now we have seen what is IB. I told you it's important equation. Bound current, just like the Ampere's law form, we will write it like this: IB equals to line integral of m dot dl. So I will substitute that here. IT minus IB, IT is this, IB is this. Okay, mathematically we are trying to find the relationship. So what I can do, line integral is common to both. I will take this subtraction, B by mu naught minus capital M. B by mu naught minus capital M. This is your total current I. Sorry, I, free charge current is I. You can compare this equation with your Ampere's law. Ampere's law, where any current I is line integral of H dot dl. Just it is resembling to that form. Because यहाँ पर आप Ampere's law में bound current नहीं लेते हो. It is because of the charges only, free charges, right? So you can compare the equation that we have got for free charge, considering the bound current and total current concept. Okay, we can compare LHSs are, for both LHS it is I. So I can compare, I can equate RHS, equate them. B by mu naught minus capital M is equals to H, because both are line integrals, right? Both are with respect to the dot product is with respect to DL. So I can equate these two terms, first two terms. Okay, so B by mu naught minus H is equals, sorry, minus M is equals to H. So I can rearrange the terms here. Take M to the other side. It will be H plus M is equals to B by mu naught. Or what is B equals to? B equals to mu naught into bracket H plus M. See, till now, whatever concept of magnetism we have studied, starting from Biot-Savart's law, Ampere's law, we have considered B equals to mu naught H, right? It resembles to that equation. Just check this. B equals to mu naught H. But now, when I talk about magnetization, I consider the property of that particular material, how well it can magnetize. So this equation, what we have derived, B equals to mu naught into H plus M, this is true for every material that exists. Okay, agar magnetization zero hoga for some materials, equation will be B equals to mu naught into H, that we have already used in the magnetism concepts. Okay, and one more important equation, I think in today's class I had written this symbol on the board. It is called chi, right? The symbol is chi. We call this susceptibility. How how the object is more prone to the magnetic field, how well it can allow the magnetic field, that is susceptibility. Okay, so what is the relationship between magnetization and susceptibility? This direct equation I have written. Okay, there is no proof of this. So remember, M is equals to chi into H. I have used the suffix M for magnetic. Okay, chi M into H. This is what the magnetization and H relationship I have taken, where chi is dimensionless quantity and it is called susceptibility, magnetic susceptibility of the medium. Medium कितने अच्छे से magnetic field को pass करेगा, that is susceptibility. Okay, so already we have derived this. Check this previous equation, relationship between B, H and M. In this we have derived B equals to mu naught H plus M. But M just now we have seen in terms of H. So let us substitute this M equation here. Okay, if I substitute that, B equals to mu naught H plus capital M. Capital M is susceptibility into H. You can take H common here outside. The equation will be 1 plus chi, or B is equals to, you can write, you can rearrange in any form. This is one more equation we got. So let us now again, we are now moving to one more important equation. This we have been using in our previous concepts, B equals to mu H. Okay, what is mu? Mu is generally permeability. of the medium, it is given by mu naught into mu r. That I have substituted here. Mu is mu naught into mu r. So whatever equation here, equation star 3, we have written, it is also for B. And whatever we are using till now, equation 4, P equals to mu H, this is also for B. So let me equate 3 and 4. So if I equate equation 3 and 4, I think I have written here from the pencil, I think it is visible to you. I have equated mu into 1 plus chi, shall I overwrite it? Mu into 1 plus chi m magnetic H. Okay, this is equation 3, and RH is mu naught mu r H. Okay, so in both terms H is there, it cancels. What you'll be left with? Here also you have mu naught, right? This is also mu naught. So I will cancel mu naught also on both sides. What you're left with? You'll be left with mu r is equals to, okay, this is mu r is equals to 1 plus chi m. This is the relationship between susceptibility and permeability that I have written. And we already know mu is equals to mu naught into mu r. Okay, mu is equals to mu naught into mu r, which is equals to what? Just now we have seen the relationship. Mu r is 1 plus chi into m. So if I take this mu equals to mu naught into mu r, let me take mu by mu naught. Taking this here in the denominator, it is equals to mu r. But what is mu r? Just now we have derived. What is mu r? Mu r is equals to 1 plus chi. So the ratio of mu by mu naught, okay, is equals to 1 plus chi m. This is one more important relationship. Mu r is equals to 1 plus chi m is equals to mu by mu naught. So now let me highlight the equations that we will be using in the problems. This is one equation, a relationship between mu r and susceptibility with mu. Okay, mu r is equals to 1 plus chi is equals to mu by mu naught. Fine. Then second equation which we will be using in the problems is this: B equals to mu naught into bracket 1 plus chi into H. Third equation, this one, M magnetization is equals to chi into H. And the last one, this B equals to mu naught into H plus M. So totally these four equations which I have written, which I have highlighted with orange box, they are being used in the problems. One is for B, one is for capital M. Again, we have B equation in terms of chi. And the last one is for mu r. These four equations we will use. You can go through your model papers. I think 1 or 2 questions are there to find this mu r, h, capital M, all these. So ये equations जो हैं boxes में, these things you will be using. Now, just an analogy, okay? Analogy between whatever we have already studied in curl, Stokes theorem, in your Ampere's law, with this magnetization concept. Generally, we write I is equals to Ampere's law, H dot dl. But when I talk about magnetization, I will become IB. Line integral is same. H will be replaced with capital M. This is one analogy. Now, second, we also know that current and current density concept. Surface integral of J dot ds is equals to I, free current, okay, conventional current that you use. But in case of magnetization, I is replaced with B, And whatever current density J I am talking, it is again with respect to the internal structure, which will be now denoted as a JB. I have written here. Okay. And suppose I want total current. It is the combination of both free current and bound current. I will write, just the subscript is changed to capital T. Okay. These things. An analogy I am giving, that's it. Now, for curl, hope it is visible to you. For curl, how we write? Del cross H is equals to J. But here for magnetization, instead of H, we will replace it with capital M. H is replaced with capital M. J is replaced with JB because magnetization, dipole moment exists because of IB, bound charges. Okay. So del cross H equals to J, we have studied in curl. Now in magnetization, it is del cross M is equals to J. These are the analogies between both. Okay. Now, I have listed some, how many are there? Some 8 formulae at one place so that you can use them in the properly, एक तरफ है तो आप अच्छे से याद रख सकते हो. First one is mu equals to mu naught into mu r. Second one, B equals to mu naught mu r into H. And this one we have already derived just now. Mu r is equals to 1 plus chi, or it is equals to mu by mu naught. Then B equals to mu into H plus M. These are the 4 equations. And this was also put in the orange box. Okay. Capital M is equals to chi into H. And chi value I have written here, mu r minus 1. How I have written that? Because mu r is equals to 1 plus chi m. So what will be chi m is equals to? Mu r minus 1. So I've substituted that here. Capital M will be mu r minus 1 into H. And talking about the curl concept, H is replaced with M. Okay. And H can also be written as B by mu naught. You know this already. Okay. Hope these concept of magnetic dipole moment, magnetization, and susceptibility, that is small m, capital M, and susceptibility, chi. This is understood by you. Important is relationship between, see, I'll just show you. How will you derive the relationship between B, H, and M? This is one thing. And whatever equations I have put in these orange boxes, 1, 2, 3, and 4, these will be utilized in the problems part. Okay. Now, let me quickly show you 1 or 2 problems. I will be sharing these things. You can go through the problems. See, given if B equals to 0.05x, so B is given to you in Tesla, only AY component is there, in a material for which chi is, I think it is hidden, it is 2.5 value. Chi is equals to 2.5. For a material, this is the susceptibility. We need to find 1, 2, 3, 4, 5, and 6. 6 different values we have to calculate. Okay. Already I have listed the formula. First, given data, 2 things are given to you, B and chi value. First is mu r. How will you calculate mu r when susceptibility is given? Mu r is equals to 1 plus chi m. You can just list all the formula at one place. What data is given to you, which equation to choose properly, that should be understood by you. That's it. Mu r equals to 1 plus chi m, which is 3.5. First thing is over. Very simple problems are there. Important thing is which formula to use. You have to remember that. What is mu? Permeability of the medium, mu naught into mu r. It is again related to the first term. एक आंसर आ गया तो first, second, third, fourth all are related. First आ गया तो second आएगा, second आया तो third आ जाएगा. So mu naught is 4.2 10 raised to minus 7 into mu r. I have got it. What is the unit of mu? It is Henry per meter. Remember this. Similarly, when we talk about epsilon, when you write epsilon naught 8.854 into 10 raised to minus 12, it is Farad per meter. Remember, this is Henry per meter. Now third question, it is H. You need to find H. How will you calculate H? This is as usual, we have used it, B equals to mu H. Generally we use B equals to mu naught H. But here I cannot use mu naught simply because medium has a susceptibility of 2.5 and the medium क्या है, एक material है. It is not free space. So इसीलिए I cannot use mu naught into H. It is mu into H. But how can I find H from this? B by mu. But mu is not like mu naught. It is mu naught into mu r. So calculate that. B is given to you in the question. You can take the ratio. You'll get the answer. Now, fourth one, capital M magnetization. H आ गया तो M आ जाएगा. Magnetization. Magnetization is equals to susceptibility into H. Direct formula is there. Magnetization M is susceptibility is 2.5 given. H already here you have calculated. So you will get the fourth one also. I am not going into the calculations. That is your part. You have to do it. And the fifth one is J. How will you find J? For finding the J, you should go for curl concept. J equals to del cross H. It is not bound. Okay. It is not del cross M. It is del cross H. As usual, regularly what equation you use, we are already, we have done such problems. Del cross H is equals to J. We have to use that because H already we have calculated. Okay. I'm taking the determinant form to find the curl. H, check the value of H. What is H? This is the answer of H, right? Same answer. It is only having AY component. That's why AX and AZ I have kept it 0. AY component is here. You can calculate this. You'll get some answer. You can verify the answers later with me. And you can see this one more. It is J. I think it is JB. Okay. Let me verify. Yeah, it is JB. What is JB? It is because of the bound charges, bound current density. So instead of del cross H, I will take del cross M. So del cross M. M we have already calculated magnetization. Here it is. Magnetization is 28.4 something. We have got this. The values are not very clear, okay? But you can verify it with me. Anyhow, I'll be sharing these things with you. Again, I'm taking the determinant. That value I have got it as 28.42 into 10 raised to 3 x in AY direction. Okay, this is the value we get. Both again x and z components are 0. Calculate the determinant, you will get this answer. See, problems are direct substitution. Just kaun sa formula apply karna hai, that you have to think. This one more problem. A ferrite material, I think this is a question paper, model question paper problem. A ferrite material is operating in linear mode with B equals to, B is given to you. Assuming mu r as 150, compare, mu r का value बहुत बड़ा है, ferrite material. So it is ferromagnetic, linear. Find chi. How will you find chi? Chi is, we know that mu r is equals to 1 plus chi. So chi will be mu r minus 1. So what is mu r? It is not given. Yeah, it is given. Mu r is, sorry, it is 150 or 50. It is 50. Okay. 50 minus 1, 49. Then you have to find magnetization M. To find the magnetization, it is chi into H. But H is not given. Instead, B is given to you. So take the help of B equals to mu H. Okay. So H will be B by mu. But mu is not simply mu naught. You have to take mu naught into mu r. Mu naught hai, mu r is given 50. So calculate H, you will get some value. H is ampere per meter. And once you calculate H, magnetization can be found. Susceptibility bhi pata hai, H bhi pata hai, H we have found. So you can calculate this. I have verified my answers whether they are correct or not by this equation. Okay. I think it is given in the question to verify. No, it's not given, but you can verify the answer. It is what? B equals to mu naught into bracket H plus M. B is given as 0.5. अभी ये जो RHS है, mu naught, H you have got, magnetization also you have got. You calculate the RHS, given B 0.5, it should, both should be same. See, I have got 0.49999, approximately 0.5. Okay. Take one more, it is simple. Find the magnetization in a material. I think some 1, 2, 3 terms are there. You need to calculate. Mu is given to you, H is given to you, mu r. Okay, I think yeah, mu is given, H is given, mu r is given, and there are some atoms that n value is given. Dipole moment के लिए कितने atoms involved हैं, that value is given to you, and each moment, each atom has a dipole moment of this. So it is something like n times m. Okay, these two you have to multiply. And third is B. So there are 3 questions here. Okay, anyhow, I'll be sharing this third problem with all of you. Please go through it. Time is less than 1 minute.